So, you've probably heard about React, maybe you've even used it, but have you ever stopped to think about why it's such a powerhouse? In this explainer, we're going to skip past the basic what is it and really dig into the why. The core ideas that totally changed how we build for the web.
And yet, we're kicking things off with a bit of an origin story. Because, you see, to really get React, you've got to understand the problem it was built to fix. It all started with this really annoying bug in one of Facebook's biggest features. And trust me, the answer to this question, well, it pretty much reveals the soul of what React is all about.
All right, let's dive right in. The whole philosophy behind React, the entire thing, really just boils down to one super powerful idea. It's this shift from telling the computer how to do something, step by step, to just describing what we want the end result to look like. And believe me, it was a total game changer.
This slide lays it out perfectly. You've got these two worlds, right? On the left, there's imperative programming. Think of this like you're giving someone turn-by-turn GPS directions. Turn left here, go 500 feet, merge right. You're controlling every single step. But then, on the right, you've got declarative. This is more like hopping in a taxi and just saying, take me to the airport. You describe the what, the destination, and you trust the driver, or in our case the library, to figure out the how.
Okay, let's make this a bit more real. Here's a super simple counter, but written in plain old vanilla JavaScript. Just look at all the steps we have to manually spell out for the browser. First, we have to create the button element. Then, we set its text content. Then, we have to stick it onto the page. Then, we have to add a listener for a click. And, this is the really important part, we have to explicitly tell it to update the button's text every single time the count changes. It's a lot of manual work.
So with this imperative approach, you're basically a micromanager. You have to keep track of every little thing and remember to update the UI every single time your data changes. Now for one little button, fine, no big deal. But what happens when you have a complex app, with hundreds of different pieces of data, all changing at different times? It becomes an absolute nightmare to manage, a total mess of code, where bugs aren't just likely, they're pretty much guaranteed.
Okay, now watch how React just completely flips the script. This is the exact same counter, but now it's built the declarative React way. Look really closely at what's not there. Do you see any code that says, update the button text? Nope. We're not telling the browser how to update anything. We just don't. React is going to handle all of that for us.
And this is the real beauty of it. All we do is declare what the UI should look like. We just say, hey, this button's text should always reflect the current value of our count state. That's it. When we call setCount to change that state, React sees the change and automatically handles all the messy, behind-the-scenes work of updating the screen. Our UI is now just a perfect, predictable mirror of our data. So much simpler.
And that brings us right back to that question I asked at the beginning. This whole declarative idea wasn't just some academic exercise. It came from a real, frustrating problem. Facebook's chat UI had this bug where the little notification count would get out of sync with the actual number of unread messages. React was born to fix exactly that, to create a system where if your data says you have 3 unread messages, the UI will always show the number 3. No more sync issues.
So this whole declarative way of thinking naturally leads us to our next big topic, JSX. That's the syntax we just saw, the stuff that looks a whole lot like HTML, right? Well, here's probably the biggest thing you need to know, the #1 misconception. It is not HTML. Not at all.
This right here. This is the secret sauce of JSX. On the left, you see what we write, that familiar, comfy HTML-like syntax. But that's just a disguise. It's what we call syntactic sugar. It's just there to make our lives easier. Because before any of this code actually runs, it gets transformed or compiled into the plain old JavaScript function call you see on the right. So when you write JSX, what you're really writing is just a shortcut for a JavaScript function.
And since it's really just JavaScript, there are a few rules you got to follow. First, you always have to return a single top-level element. You can't return 2 buttons side by side. They have to be wrapped in something. Second, you'll notice attributes are in camelCase, like class name instead of class. Why? Well, because these become keys on a JavaScript object, and class is a reserved word in JavaScript. Third, and this is a big one, JSX doesn't create HTML. It creates lightweight JavaScript objects that describe what the HTML should look like. And finally, the coolest part, you can pop any JavaScript expression right into your markup just by wrapping it in curly braces.
All right, so let's do a quick interview pop quiz. If someone asks you, is JSX required to use React? The answer is a firm no. You can always use the React.createElement function directly. Is JSX just HTML? Absolutely not. It's a JavaScript shortcut. And why do we use camelCase? Because those attributes become keys in a JavaScript object. Nail these 3, and you'll sound like you really know your stuff.
Okay, let's talk about our final core concept. This one is huge for performance, but it's something a lot of people get wrong. I'm talking about keys. Whenever you're rendering a list of items, keys are like React's secret weapon for making sure everything updates super fast.
So what is a key? Well, it's pretty simple, really. It's just a special, unique ID that you give to every single item in a list. But why does React care? Imagine your list changes. Maybe an item is added or the order shuffles. React uses these keys to figure out exactly what changed. That way, it doesn't have to waste time re-rendering the entire list. It can just update the 1 or 2 things that are different. It's a massive performance boost.
And this slide shows the classic do this, not that. On the left, we've got the right way to do it. We're using a stable, unique ID that comes from our data, like todo.id. Perfect. But on the right, oh, this is the common mistake. Using the array index is the key. This is a bad idea. Why? Because if you sort that list or add an item to the beginning, all the indexes change. React gets totally confused and can't keep track of which item is which can lead to some really weird bugs.
You know, if the code still feels a little abstract, think about it this way. Using a stable ID, like item.id, is like using a student's unique roll number. That number belongs to them and only them. It doesn't matter if they change classrooms or switch seats, you can always identify that student. Now, using the array index, that's like using their seat number. If all the students get up and move around, well, seat number 3 is now occupied by a completely different person. See the problem? It causes total confusion for React.
Now, I will say there's one tiny exception to this rule. You can get away with using the index as a key, but only if the list is totally static. And by static, I mean the items in the list will never, ever be reordered, added, or removed. If you can guarantee that, then sure, the index is fine. But it's rare.
Phew! Okay, we've covered a ton of ground. So let's wrap this all up with a nice, clean cheat sheet that really drives home the why behind these core React concepts.
Okay, this is your takeaway slide. If you're going to remember anything from this, make it these 3 points. 1. React is declarative. You tell it what you want, and React figures out how to do it. 2. JSX is not HTML. It's just a nice-looking shortcut for writing JavaScript functions. And 3. For lists, always use stable, unique IDs for your keys. Avoid the array index unless you have no other choice. Got it?
So, there you have it. You now understand the fundamental why behind React's design. But it kind of raises a new question, doesn't it? If we're just describing what we want and not telling the browser what to do, how in the world does React update the screen so darn fast? Well, the answer is something called the virtual DOM, and that's exactly what we're going to break down in the next explainer.